Okay, thank you. It's great to be here presenting at the NSO Dev Days. I'm Marko Zagožen, and I'm a consultant at Flint International. Together with the team over at Deutsche Telekom, we created a package for declarative device management in NSO, and we call it the device automaton. Let's look at the problem we solved a bit. Today, to add a new device in NSO, you have to manually create a new device list entry, assign the name to the device, associate it with a management address, configure the credentials by creating the auth group and then linking the auth group with the device, and finally configuring the correct NAID ID in the device type container. You then commit this transaction, and then in the next step, you fetch the SSH host keys, and only then is NSO ready to sync the configuration into its CDB. So in total, there's at least 3 steps or actions required to be taken before you can configure any services that use this device. If at any point in time the device is unreachable, this process has to stop and must be restarted when the device is available. So we thought about coming up with a better way of doing that, and we came up with a stack of services that exposes a interface to our network that allows us to create service configuration or push service configuration and device configuration in a single transaction. So device automaton is one of the components in the service stack that exposes a declarative interface just for device management, meaning you can use it to create an instance that contains all the data required for adding a device in a single transaction, and it's going to perform the iterative steps in the background for you. So it's best to show you how it works by doing a quick demo. So I'll now switch to a terminal and we'll create a test instance. Okay, so in this NSO instance, I currently have no devices. I'm going to paste some configuration, and then I'll explain the parameters. So this is the bare minimum required to create an instance of the automaton, starting with the name, which will end up as the device name in NSO. Then we have the NAID ID, which in this case is set to Cisco iOS CLI. Those of you that have added devices before know that the NAID IDs typically contain a version number, like Cisco iOS CLI 6.67, but the automaton is actually aware of the hierarchy of NAID IDs, which are Yang identities in NSO. So if you specify a family, an abstract NAID ID or a family of NAID IDs, it's going to automatically pick the best fit for that given family. In this case, because this is a CLI net, it's going to select the highest version number NAID ID it can find in this NSO instance. This is slightly different for netconf, but I'll explain that a bit later. Next, we have a management endpoint, which is actually a list of management endpoints that are monitored periodically in the background for reachability, and the automaton can reconfigure the address NSO uses to communicate with the device based on the reachability of these endpoints. And finally, we have the credentials, the management credentials that NSO uses, which in this case are just username and password, but can be configured to use SSH keys as well. So if I commit this instance, we should see the device being added. It did pop up. And we can also observe the progress of the automaton by looking at its plan. And we can see that this instance has actually failed at this state with the error message that no working initial credentials were found. That was intentional. The device I have in the lab has factory credentials set to Cisco, but I really wanted to use admin as the final management credentials. So the automaton can also be used to change credentials, delete factory credentials, for example. So we're going to tell it to do that by adding some more configuration. Excuse me. By adding the initial credentials to the management endpoint, but keeping the admin management credentials in the instance, We tell it to first try the initial credentials, and if those exist, remove them and replace them with the management credentials. So after I commit this change, the automaton restarts its process in the background, and we can again observe the progress by looking at the plan. And we should now see the plan go past the initial credentials configured state, go past the management credentials configured state, and finally reach the ready state, which means that the device is fully synced and NSO has the correct credentials and can also reach the device. So at this point, the device is ready to accept configuration from other services. Okay, let's switch back to the slides. And let's briefly describe some of the other features that I didn't show you. I showed the declarative interface, the ability to monitor connectivity to multiple management endpoints. You can configure the automaton to accept the first SSH host keys of the device it sees and then sticky it, or accept any SSH host key on the device as it changes. We also shown how to use the automaton to change the device management credentials, including removing the factory credentials. And I also showed you how it set the correct CLI NetID with the version number, given only a family of NetIDs, the Cisco iOS CLI net. For Netcom devices, this is a bit more advanced because the automaton can look at the advertised capabilities of the device and compare those with the currently loaded Yang modules provided by the nets and select the best fit for a Netcom net automatically. The next set of features comes into play more in the later stages of the device lifecycle. For example, enabling commit queues in NSO is quite trivial, but it's non-trivial to actually use them. So the automaton can monitor the commit queue and unblock a locked queue, for example. You can use it to perform NetID migrations, either automatically or explicit migrations if you set an explicit NetID version. The automaton will also monitor the device configuration in the background, so check the sync state. And if the device falls out of sync, it can either do a sync from or a sync to. And in addition to that, it can also notify other services that the device configuration has changed, and they may want to check their sync state as well. Usually this is done with a redeploy of the services that use the device. And of course, there's more features that are still in the pipeline, so I encourage you to check the repository if you actually do use it. So the best way to start using the automaton right now is to reserve Cisco NSO reservable Sandbox in DevNet Labs. In there, you will find an NSO instance and a couple of virtual devices, and you can clone the device automaton repository from gitlab.com. The URL is shown on the slide. In the repository, you will find the DevNet Sandbox directory with instructions on how to add the automaton package to the NSO instance, and also instructions how to use it to add one of the devices in the lab to that NSO instance. So I think that's the fastest way to get a feel of the full set of features of the automaton, and I encourage you to do it yourself right now after this session. Okay, so thank you for your time. I hope this has been useful. And now I'll pass control back to Jason.